Hi and welcome to Unit 2, Topic 1, Video 1, Complex Numbers. And in this video I'm going to introduce complex numbers, and in the following series of videos we're going to go through complex number arithmetic and some of the basic principles behind complex numbers. Now, in my opinion, this topic's not too tricky as long as you recognise that the work you're going to be doing not only falls back on your past work in arithmetic, but also some of the work you've done in vectors and matrices recently. And so it's just an addition to that. The big thing here is you need to understand what a complex number is, and to do that you need to understand what an imaginary number is. And if you can develop that understanding, then the rest will fall into place quite nicely. Learning goals and success criteria, that as usual. And here we go. So a complex number has two components. Firstly, it has this a, which is the real component. That's just a number. 10, 50, -5, pi, whatever. And then we have b plus i. bi. Now, forget about the b for a second. That's again just the coefficient of I, so it's just a number. 10, 50, -5. It's the I that's important. I is equal to -1. Now, you've been in situations in the past where you've had to deal with calculating where you've got square roots of negatives. So, for example, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you've seen this before. It's the quadratic formula. We all know and love it. The problem with the quadratic formula is this discriminant, b squared minus 4ac, and you're told, well, if that's negative, we have no solutions to the quadratic. And mathematics really doesn't like to work in that situation where, oh, there could be 2, there could be 1, there could be 0 solutions. So actually, technically, if we work within the imaginary numbers or the complex numbers, we have always got two solutions. And it's just a different way of looking at things. So now, if we do the square root of a negative, we get a complex number. So I is equal to the square root of -1. And if we want to calculate the square root of -2, well, that's going to be equal to, well, actually, -2 is not a good idea. Let's do -4. And you know your surds, that becomes the square root of 4 times the square root of -1, which is 2i. So that's where that I comes in. Now, the square root of -1 isn't real, it's imaginary. That's a big thing that you need to remember. So what's the difference between imaginary numbers and complex numbers? Well, it all comes back to this form here. An imaginary number is I, or 7i. A complex number technically has a real and imaginary component. So just keep that in mind. If we're looking at complex numbers, we're considering the real and the imaginary, whereas if we're looking at just imaginary numbers, we're only considering the imaginary part. Here's a number system that you know and love. N, this central one here, well, that's the natural numbers, the counting numbers, and 0. So you've seen them before. And then we have Z. Z, that's the integers. So it includes the natural numbers, but it also includes the negatives. -3, for example. And then we've got Q, which is the rational. So Q includes all the integers, but it also includes any number that can be written as a fraction, A over B, where A and B are integers. So for example, 7/3. And then we have R. R is the real numbers. Now you've seen R, and R is any number, any real number that we've dealt with in the past before. It's Q, all the rationals, plus the irrationals, plus pi, or root 3. And then we have C, the complex numbers. So of course C is inclusive, technically here, C includes all the imaginary numbers, even if they don't have a real number component. So it could include 7i, but it could include 2 plus I. They're both complex numbers that aren't real. Okay, so that's the number system. Let's look at some complex operations. Firstly, we do have to dabble with the powers of I a little bit, because they're important. So I is the square root of 1, whereas I squared is equal to -1, because if you square the square root of something, you just get that thing. In this case, you square the square root of -1, you get I. So you get -1. And then I cubed, well, that's kind of like -1 times I. And so it becomes -I. And then I to the power of 4, well, that's kind of like -I times I, which is kind of like -I squared, which is -1, and that's I. And now just to add to this, we get I to the power of 5, which is kind of like 1 times I, well, kind of like equals I. So we end up actually back where we started here. We've got a four-way cycle. So we've got our I squared, I cubed, and I to the power of 4, and it cycles around in a circle like this. And it goes back to I. So this is where every one of these arrows represents multiplying by I. Another way of looking at it is that we have I, which is the square root of -1, and then we have -1, and then we have negative the square root of -1, and then we have 1. Every time we multiply by the square root of -1, it just goes along that process and then back to the square root of -1 again. Another way of looking at it is that the square root of -1 is I, so we get I, then we get -1, then we get -I, and then we get 1, and go back, which is the most common way we're going to see of looking at it, but this is what's happening when we're raising those powers. This is really important when we get to the multiplication and a little bit division of complex numbers, because when we start multiplying complex numbers, we don't want to end up with 7 plus 2i plus 14i squared minus 6i cubed. We simplify those and we end up with a whole number, or a real number, sorry, and an imaginary number. So we can simplify those powers, which is great. Addition and subtraction works exactly as you would expect. So in this case, we just start by dealing with our real parts and then our imaginary parts and bringing them together. So let's start with the real parts. Well, let's start with the simplification. I'm going to expand the brackets because that's always a good way to start. So this one's pretty easy and trivial. Probably didn't need to do that step, but 2 plus 5 is 7. 3 plus -I is plus 2i. That works as you'd expect. And here's one that I've written on before for some reason. Expanding this, I'm going to do the same thing again, because this time I've got a negative here. And that's a bit of a problem sometimes in the expansion, so let's be really careful. 3 plus 2 minus I, minus 3, and then minus makes positive 2i. So however you want to set that up, just remember that that negative is applied to the second term as well. 3 plus 2 minus 3 is 2, and then -I plus 2i is plus I. So we get 2 plus I here. Okay, that's example 1. Now let's look at that scalar multiplication idea. So this is a lot like our work with vectors. So I've defined here Z1 and Z2. 2 times Z2 is equal to 2 times 3 minus 2i. And that's equal to 6 minus 4i. So that works exactly as you'd expect, just with that binomial expansion. 4 times Z1 minus Z2, this is part B, that's equal to 4 times 2 plus I minus 3 minus 2i. Always remember to put that in brackets because we're subtracting all of Z2, and Z2 has two components, a real and imaginary component. 4 times 2 is 8, plus 4i, minus 3, plus 2i. I've got negative of negative there now. That gives me 5 plus 6i. Okay, and then C, we've got a solve question. Find the value of Z3. So I know Z1 and Z2, so I can put those in, but actually what I'm going to do now is if I substitute in Z1, and it's on the same side as Z3, well then I've got a two-term beast, and I've got to rearrange with that. So I'm going to rearrange with Z1 first. I get Z3 is equal to 5Z2 minus 2Z1. You notice I put a stroke through my Z's to distinguish in between the Z's and a 2. And I've done a subtraction of 2Z1 from both sides in order to make the rearrangement before I substitute. So Z3 is equal to 5 times Z2, which is 3 minus 2i, minus 2 times 2 plus I, which is my Z1. And it is my Z1, isn't it? Yeah. That's 15 minus 10i minus 4 minus 2i. And that gives me 15 minus 4 is 11 minus 12i. Okay, so there we go. And we also have our multiplication of complex numbers. So this works exactly as you expect as well. A little bit like binomial expansion. 2 times 3, I times 3, 2 times negative 2i, I times negative 2i. So you can do it like that. That's the crab clause method. But really the best way to do it is to just apply the distributive law. I'm going to distribute the first bracket over the second. I get 2, 3 minus 2i, plus I, 3 minus 2i. And that gives me 6 minus 4i, plus 3i minus 2i squared. Remember, I squared is -1, so it becomes 6 minus 4i plus 3i is just minus I, and then minus 2 times -1, which actually makes plus 2, so I end up with 8 minus I. Now, with a bit of practice, this doesn't really need 4 steps, but it's a good idea to show while you're working and make sure that you're demonstrating what you're doing. Question B here, Z1 equals that, Z2 equals that, Z3 equals this. It's just going to remind us of a couple of rules. So I'll just stick a bit of space in here so we can separate them. Z1 times Z2 is equal to 2 minus I times 2 plus I. And hopefully you remember the old A plus B times A minus B is equal to A squared minus B squared. That's the difference of two squares rule. So you could do the full expansion here. Things will simplify nicely. It won't really take that much longer, but we remember the difference of two squares. So 2 squared minus I squared becomes 5 minus -1, which actually becomes 6. So that gives us a real number. Two complex numbers multiplied can give you a real solution. And then we have Z3 times Z2 squared. So that is 3i minus 2 times 2 plus I squared. Now again, I could apply a rule here. Remember that A plus B squared is equal to A squared plus 2AB plus B squared. It doesn't actually really save us that much time, but that is our perfect square expansion. So I'm going to do that. I'm going to start by expanding this square here, and it gives me 2 squared, which is 4, plus 2 times A times B, which is 4i, and then plus I squared. Now remember, this will always simplify down to 2 terms, so I get 3i minus 2 times by I squared is -1, remember, so 4 minus 1 is 3 plus 4i, and now I can expand this. So I get 3i times 3 is 9i, so I'll do it a little bit quicker here. Minus 2 times 3 is 6, and then 3i times 4i is plus 12i squared, and then minus 8i. Now 9i minus 8i, I hope you agree, is I, and then 12i squared is -1, so it's minus 12, so I end up with minus 18. I minus 18 or -18, -18 plus I. So there's part B, and we're on to division of complex numbers, which I'll put in the next video. So take some time now, go and practice some of those skills in the first exercise, and make sure that you're up on top of things, and then ask if you need to. All the best.